All right, so in this video, we're going to talk about solving systems of equations, again, using the combination method, okay? But in this case, I call it forced, because if you look at these two equations, you don't see opposite coefficients for either the x or the y, okay? 3 and -1, 2 and 4, those are not opposites, okay? So I can't use the combination method without forcing a situation where I can use that method, okay? So let's go through the steps here. First off, we want to make sure our equations are in standard form, just like we did in the previous set of notes, okay? We got to have a canceling situation, just like we talked about in the previous set of notes, okay? In this case, you're going to have to multiply one or both equations by a constant to force that canceling situation, okay? So in this case, we're only going to multiply one equation to create that situation, okay? But in the second example, we're actually going to have to multiply both equations to create that canceling situation, okay? Then we're going to add the equations together so we can solve for one variable. And then, we'll continue on the way we have with the other methods, finding the other half of the answer, okay? So if you look at number 1 here, I'm going to choose to cancel out the x's. So I've got a positive 3x. I want to make this a negative 3x. So I need to think about what number can I multiply this entire equation by to create this canceling situation, okay? So if I multiply this equation by 3, okay, I'm not going to change the first equation. So if I multiply this equation by 3, okay, I'm going to create that canceling, or I'm going to force that canceling situation. So when I distribute a 3 times all of these terms, I get negative 3x. So 3 times negative x is negative 3x. 3 times 4y is 12y. 3 times 5 is 15, okay? So now we've created a situation where we can use the combination method, okay? So now I'm on to step D. I can add the equations together so the x's will cancel out. So let's add the equations together. Notice the x's cancel out. And I'm left with 14y equals 28, okay? So a real simple equation I can solve for y. I'm going to divide both sides by 14. Those 14s cancel out, and I get half my answer, y equals 2. Okay? So again, by this point, you should be comfortable with the rest of the process, but we'll still show it. Remember, I want to go back to one of the original equations. Okay? I'm going to choose to use the first equation here to find the other half of my answer. Okay? So I've got 3x plus 2y equals 13 that I'm going to be using. So let's substitute in 2 for y here. So I get 3x plus 2 times 2 equals 13. So that's 3x plus 4 equals 13. I want to subtract 4 from both sides. That way I can start to get x by itself. Those 4's cancel out, which leaves me with 3x equals 9. Okay. Now I'm going to divide both sides by 3. And I get the other half of my answer, x equals 3. So remember, my answer's an ordered pair. 3 comes first because it's x. So 3 comma 2 is my answer now. As always, you want to plug this answer back into both of the original equations to make sure that it's actually the solution. And in this case, it is, okay? So that's number 1, okay? So let's move on to number 2. All right, so now we're looking at number 2, okay? And notice that in this case, there's not one number that I can multiply either of the two equations by to create that opposite or canceling situation, okay? So I'm going to choose, in this case, to cancel out the y's, okay, because I think that's the easiest way to go. So if you'll notice, I've got a negative 3y here and a positive 2y. And the reason I start with the y is because I've already got the different signs here. So I can multiply both equations by a positive number to create that canceling situation. So the least common multiple, if you'll think back to, elementary school, early middle school, the least common multiple between 3 and 2 is 6, okay? So if I multiply this first equation by 2, okay, then I'm going to get 4x minus 6y equals negative 2, okay? So that y term, again, I'm going to try to cancel out the y's. I get a negative 6y here, okay? So I need to ask myself and think, what can I multiply by 2y to get positive 6y? So I'm forcing that canceling situation. So if I multiply this equation by 3, okay, then when I distribute the 3, I get 15x plus 6y equals negative 93, okay? So you can see now that I've forced the canceling situation. My y's are going to cancel out when I do the last step here, add equations together so that one variable cancels out, okay? So now I can use the combination method because I have those opposite coefficients for one of the variables, okay? So those are going to cancel out. 4x and 15x gives me 19x, negative 2 and negative 93 gives me negative 95, okay? So divide both sides by 19, and I get half my answer, x equals negative 5, okay? So remember, I want to plug into one of the original equations, always important to remember that. So I'm not going to use one of these two, just in case I made a mistake. So, you know, either one of these we could use. I'm going to use the first one, 2x minus 3y equals negative 1, okay? So as always, I'm going to substitute negative 5 in this case for x, okay? Let me scroll down a little bit. So that gives me 2 times negative 5 minus 3y equals negative 1. So 2 times negative 5 is negative 10. I'm going to add 10 to both sides, all right? So these 10s are going to cancel out. So that gives me negative 3y on the left side equal to positive 9 on the right side, okay? Now we want to get y by itself. We're going to divide both sides by negative 3. And that leaves me with my other half of my answer, y equals negative 3, okay? So I've got my x coordinate, I've got my y coordinate, and that gives me my final answer of negative 5, negative 3. Again, as always, make sure you plug both coordinates into the original equations, both of them, just to make sure you get a true statement, okay? And I can promise you that's going to be the case because the answer is negative 5, negative 3. Okay, so that's how you use the combination method when you have to force that canceling situation.